Hey, good morning. I hope this is going to work. Last time I tried to stream with this setup, it was flicking a lot, and right now, uh, YouTube Studio for some reason is not showing uh, my stream, but my video is working on the channel. Anyways, uh, So after a long time, I'm coming back to my streaming routine, and today's plan is to see if I can return this code base to into a zig based source code. Let me move this camera a little bit. I think this is better now. Yeah. So with that being said, the idea is I want to pick exercise from this Lego kit that I have, which is a Lego Mega Starter Kit. Let me see if I can find it. Lego Mega Starter Kit. Yeah, this is the one I think. Yeah, this is the kit I have, and I want to basically do one of these exercises to start with. But if this works out, I'm going to basically teach myself Arduino using Zig programming language. As you know, Arduino is usually programmed using a variant of C++, I believe, and via Arduino Studio, which I also have, I believe, installed Arduino IDE. It's very comfortable to work with. You basically put your code somewhere in the IDE and select the board that you have, and then upload, and everything works, right? But I want to stretch this a little bit, and first of all, I don't like Arduino IDE's interface. I want to have my usual programming interface, which is Emacs in this case. So I want to be able to edit my code here and upload it. That's also possible by Arduino Studio. Arduino IDE, but there is another tool that I have recently used, which is PlatformIO, which is quite interesting. I had a bit of a challenge to run some of this stuff on NixOS a while back. I did this exercise, I think, about a year ago. I barely remember there was some configuration, but I have the project that I did, so I can reuse the code from there. But yeah, the idea is first I'm going to read the exercise, make the circuit board on this breadboard. I'm going to use this Arduino Mega prototype board, and then run the C++ code. When everything works, meaning my circuit is complete, I'm going to start porting that source code, which is example provided by Lego, by the way, into Zig, and try to see if I can compile it. I remember that I've read some articles around it, but I'm going to research it again. So let's start. Lesson for RGB LED. There are 3 other lessons, which I think there wasn't any source code for, or I didn't have the badge for it. But for now, I'm going to start from this. It's to me, it is as good as any other exercise here. RGB LEDs are a fun and easy way to add some color to your project, since they are like 3 regular LEDs in one. How to use and connect them is not much different. They come mostly in two versions, common anode or a common cathode. Common anode uses 5V on common pin, while common cathode connects to ground. Okay, which version do I have? As with any LED, we need to connect some resistors in line 3 total, so we can limit the current being drawn. In our sketch, we will start with the LED in the red color state, then fade to green, then fade to blue, and finally back to red color. By doing this, we will cycle through most of the color that you can be achieved. Okay, and the component required is a Lego Mega 2560, the breadboard, the wires, male-to-male wires, and RGB LED, and 3 220 ohm resistors. Component reduction. At first glance, RGB LEDs look like regular LEDs. However, inside the usual LED package, there are actually 3 LEDs, one red, one green, and yes, one blue. By controlling the brightness of each of the individual LEDs, you can mix pretty much any color you want. And we mix colors the same way you mix paint on a palette, by adjusting brightness of each of the 3 LEDs. The hard way to do this would be to use different value resistors, as we did in lesson 2, but that's a lot of work. Fortunately for us, Mega 2560 board has an analog write function that you can use with pins marked with tilde to output a variable amount of power to the appropriate LEDs. The RGB LED has 4 lids. There is one lid going to positive connection of each of the single LEDs within the package, and a single lid that is connected to all 3 negative sides of the LEDs. Okay. I think with that being said, the tallest pin is cathode, I hope. Also, looking inside the LED, that looks like it. The one that connected to this is the cathode, because I'm not sure if it's visible in the camera that much, but I've already changed the structure of this LED pins a little bit, so it's difficult to figure that out. I'm going to rely on this deduction that this longest one is the cathode. And here on the photographs, you can see 4 electrode LED. Every separate pin for green or blue or red color is called anode. Let me actually check that out, how it is pronounced.
Anode.
Anode, okay, that was correct. And then you will always connect plus to the positive, and cathode goes to negative ground. If you connect it other way around, LED will not light. The common negative connection of the LED package is the second pin from the flat side. Okay, it is also the longest of four. Okay, that action was correct. Each LED inside the package requires its own 220 ohm resistors to prevent too much current flowing through it. The three positive leads of the LEDs, one red, one green, and one blue, are connected to Mega 2560 output pins using these resistors. Okay, and here we have some color theory on light paint. We have red, blue, and green as the main color, main lights, and then mixing them you can get different type of colors. Theory pulse width modulation is a technique for controlling power. We also use it here to control the brightness of each of the LEDs. The diagram below shows the signal from one of the PWM pins on Mega 2560. Roughly every 1/500 of seconds, the PWM output will produce a pulse. The length of this pulse is controlled by the analog write function. So analog write 0 will not produce any pulse at all, and analog write 255 will produce a pulse that lasts all the way until the next pulse is due. Okay, so that output is actually on all the time. If we specify a value in the analog write that is somewhere in between 0 to 255, then we will produce a pulse. If the output pulse is only high for 5% of the time, then whatever we are driving will only receive 5% of full power. Okay, I'm not sure if I'm following it. Okay, maybe I see the code and I will figure it out. If, however, the output is at 5V for 90% of the time, then the load will get 90% of the power delivered to it. We cannot see the LEDs turning on and off at that speed. So to us, it's just looks like the brightness is changing. Okay. So the connection, let's figure this out. I need to have this. Okay, hopefully this is fine. And then for the three positives, actually it's better to turn it around. So I'm exactly following how it is visualized, and then pick my register up. So I have all three connections in place. I'm not sure how visible this will be inside the video, but you can see the results, fortunately. If it works, of course. And now I need three colors. It's using green, red, blue. I can have yellow, red, blue here. And from here, blue is number 3. Green is number 5. And red is number 6. And then I need a black one, which goes this. Actually, why? Let me actually use a pin down here. Hopefully, I'm correct. And put it on G and D. Okay. This is it. And then here it is describing the code. Okay, it's not describing the whole code, it's just after wiring, please open the sketch in folder tutorial English, yeah, and then upload it to the board. And then the setup is pin mode, red, blue. Okay, before we take a look at the loop function, let's look at the last function in the sketch. The define variables. Okay, let me see if I can follow this. There are basically two functions in why there is no indentation in this file? It's better now. So basically there are two main functions inside an Arduino program. There is setup, where we indicate the pin modes, and here we are also doing digital write. This happens once, to my understanding, to start the program, and then there is a loop which is continually going to be executed on each cycle of the microprocessor. And then here we have the main logic of the program. So basically here we are defining pins 3, 5, 6 as the output pins, and these are the pins we configured here, 3, 5, 6 according to their color, and then we write an initial value for them. So the initial value would be red. We're setting it to high, and then for the rest we are setting it to low. So initially the LED will show the red color, and then we are going to start a loop. And for the loop, there is a delay of, it is probably 10 milliseconds, right? And then red value full. So at the start of the cycle, it will begin red. This is unnecessary as we've either turned on red in the setup or in the previous loop. Regardless, this turns red off. Okay. For fade out red, bring green full, and okay. So basically we are cycling from 0 to 255 exclusive, and then we are reducing the red value by 1, adding the green value and writing the values, and there is a delay for each loop that we are doing of 10 milliseconds. Again, the same thing is going to happen here. I think this would be unnecessary. It's just maybe precaution to make sure the values are set correctly, and then again do the same logic, reset, do the same logic, and go back. Okay, so we have the circuit, we have the C++ program, and now let's create our new project. CD sorcery projects. I'm going to create PDIR Robotics and Arduino Mega. And then what I want to do is to get an init here. In the meantime, get us started. PlatformIO has an ID. I think it's a web browser based, and then a CLI. Then you need to init your project. Okay. Documentation, getting started with PlatformIO core. Platform Core IO is the heart of the entire PlatformIO ecosystem and consists of installation, quick start. PIO project init command requires to specify board identifier ID. It can be found using board catalog, boards explorer, or PIO boards command. For example, using PIO boards, let's try to find Tinsy boards. According to the above, the ID Tinsy 31. Also, the ID for Arduino Uno is Uno, and okay. Okay, let's see what would be. Okay, let's do this, and then mkdir rgb e dev mix. Here I would like to I think the package was called PlatformIO. Open source ecosystem. I think PlatformIO is the one I want. It includes everything. And then here you can, for now, actually, can I remove everything? Or let's have the language, because that we are going to get back. Unix, what is the error? This is the error. Cool. And now I should have PIO. Okay. I can cheat. I probably have the history of the commands I was using. I want to also do git init here. And git add git. Yes. Visible. I don't have anything in my working right now. Now go to RGB. History, grab PIO. Okay. Let's do this. PIO. Okay. Okay. That's mega at mega. This is the last initialization command I've used. Maybe in the meantime also connect my board. Yeah, it initialize some configuration, but I need to add some stuff from within percent. So go to exploratory projects. Where was I? PWD projects, workbench, Arduino Mega. Okay, and then I have dev. So close this one. Cool. Keep this one for now. Initialize the project. We do the initializing. But PIO boards. Okay, it's a lot of boards. Then can I do Arduino Mega? TNC Mega. Atmel AVR. Nice. So this is how you figure out what you want to run. Okay. And then initialize the project. Okay, these are the commands that I need. But I think let's open this and then the RGB. If I do PIO run, please put the source code in SRC. Okay, what should it be called? main.cpp. And move to copy this. Move it over. Now you have it. Okay, I have this figured out before, so I'm going to use those learning Arduino RGB. Let's start with the dev setup that I had here. C-Lang tools, Arduino CLI. Okay, I'm going to use it one by one to figure out what is going to solve what. Right, so come here, go to dev and next the dev and the other one. Did I close the or I didn't even open it? Yeah. So Arduino CLI glibc multi. Okay, this didn't solve anything. Probably this is for upload only. glibc multi. Again, nothing from this one. Packages, costs, AVR, build, packages, BCC. I remember I changed two things specifically for this setup. It was dev of course, for setting up the dependencies, but also PlatformIO ini needed some extra flags to work inside. Okay, these didn't work much. Let's second go to RGB PlatformIO ini. Yeah, these build flags -I leave and -I src. No change. Or I need to include something maybe. src main.cpp. Arduino.h I need to include, I believe. Okay. Now it still shouldn't run good. Oh, interesting, compiled. What happens if I hide this? Actually, it's like this. Why in the wrong place? Right place, yeah. Okay, then can I put it on my board? PIO run target upload. It uploaded something to my board, but I don't see it working. You can see if everything is correct. Okay. Yes, it was the cathode connection that wasn't working, but I'm not sure again. If you see the light here, it is changing. Yeah, you see something. At least it's reflections you see. Okay. This worked, and to my surprise, I didn't need to change much. Maybe something in NixOS configuration. NixOS setup has been updated recently to support this PlatformIO without this requirement. Okay, then let's go back and inside and add the goodies that I had. I think, oh, this package I kept. Let's try without this. Yeah, even without that, it's working well. So for now, I'm just will leave them commented out. Arduino language server is the only thing I'm going to use. And Silang tools, I'm not sure if I need that right. And that being said, let's start spending some time with the Zig setup now, because our program is kind of working. And before doing so, also Zig PlatformIO. Zig Arduino Pico example, it's using PlatformIO. So, to my understanding, the actual library we are going to eventually use, which is basically what tools like PlatformIO provide, are the Arduino libraries in C++. But my idea is, if my part of the program, the logic that I'm going to code, could be represented in Zig. In theory, it should be possible, and apparently people have done it before. So let's just start with this one. A simple but fully functional striking clock framework for Raspberry Pi Pico based on this, using PlatformIO with core logic written in Zig. If you want to actually make the thing wire Pico, that's not what I want. Install Zig and install PlatformIO, set SSID and time zone. Why Zig is a small, highly rigorous, and extremely performant language for close to the metal programming, ideal for embedded systems. How? We have a main CPP with the standard Arduino setup as loop entry points. These call into equivalent entry points in our Zig library. We have a hardware abstraction layer written in C++, containing all the API functions exposed to Zig. this is split into the standard C header file and the C++ implementation file. We have a Zig source file which exports its own setup, a loop entry, the same. Okay. C. There is a main CPP, external core loop, core setup, and then in hardware abstraction layer the header is used by both. Okay. So we have core setup here. And how the builder script is working, it just says Zig will leave this build core is putting live core into bin, building a live core basically. To bin, and PlatformIO is going to compile using the live core. MCPU is defined. Let's see. Music will compile for your combination of CPU and OS. This can be used. Okay, we So should I check for AVR? AVR X Mega. Okay, there is at Mega 2560. So let's do this targets. AVR 6. XRC. Okay, let's go to this RGB SRC main.cpp and basically remove all of it, right? And then extern C, cp void, let core loop and core setup. Core loop void and void setup void, and inside both of them are also void, right? Void setup setup. So basically, to my understanding here, we are importing what the library, external library, is providing, right? And then inside core.zig, what do we do? Let's do for the functions, they are public and exported functions, right? So export for setup export core loop. Then I have here, right? Here I want to set pin mode. My question is, how can I do so? This is not going to work. Like, I want to see if I need to import Arduino.h here as well, or I can just call these functions. Or what they were doing here maybe is the answer. yes, digital write and stuff like that are happening here. So now I don't understand what is the benefit of using Zig in general. Yeah, there are some logic here, but basically what they are doing is making a layer of abstraction which needs to be maintained in CPP. But is it mandatory? Maybe I can just do import like Arduino. What is wrong with you? And then at the import. What is the error here? Arduino that edge not found. Okay. What is the error here? True. What was the signature here they use? Okay, signature callcon.c. Mm-hmm. Mm. Okay. Not sure if I need to continue because I'm already past my 1 hour. But this is something I need to also dig deeper in the next session. Arduino.h wasn't anyhow available, right? This is for my setup. Yeah. But now I'm wondering, if I can have this data, right? Call it Arduino dot inode const blue const green 5 and const red 6, right? And here blue would be Arduino output. And then Arduino that digital, right? I'm pretty much sure this shouldn't be the way it is. But we will run. Let's see, we have this, right? And then when compiled, they are compiling using this, right? SRC is correct here. The targets mega 2560 AVR6 I'm not sure if I need to. Okay, AVR6 is then it's at mega 2560 on no CPU. Okay, nice. So available CPUs for architecture. So these are the CPUs. Should I say AVR? Maybe that's what they mean by freestanding DVI. What's the problem with this? Switch to the variable. FN. This is it. Here we are now built in. Okay, let's see. Call con. Zigzag. Call con. Yeah. Calling conventions. Describe how functions are called. This includes how arguments are supplied to the function and how the return value is received. Is a call conf may be given to a function. The calling conventions available may be sick. But that doesn't exist. .c. Okay. Seems like something is deprecated. Okay, let's remove this. Let's see why Arduino is not available. I doubt Arduino is still live, will solve the problem. Oh. Okay, this is something I need to figure out. It's enough for today. So far, the circuit is working. We found our first duplication in Zik, which is a good sign, I guess. And then now the problem is this library is not found inside my patch, which is true for the C++ compiler as well, as far as I see. But somehow the compiler for PlatformIO is resolving it, so it's able to upload, but my Zik compiler cannot find the library. So I need to figure out how I can map it. It's already in the system, but how it's going to be found is something I need to figure out in the next session. Yeah, if you have been following me so far, thanks for watching, and see you in the next one.